This PowerPoint is on similar triangles. First we have AA similarity. This is otherwise known as angle-angle similarity. If the two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So down in the picture, notice that angle A is congruent to angle D, and angle B is congruent to angle E. So by AA similarity, triangle ABC is similar to triangle DEF. Now we have SSS similarity, otherwise known as side-side-side similarity. If the measures of the corresponding sides of two triangles are proportional, then the triangles are similar. That means that the ratio of their sides are the same. So AB over its corresponding side DE equals BC over its corresponding side EF equals CA over its corresponding side FD. So by S side-side-side similarity, we have triangle ABC is similar to triangle DEF. Now remember that we don't want AB to be congruent to DE, just the ratios of their sides are the same. SAS similarity, otherwise known as side-angle-side similarity. If the measures of two sides of a triangle are proportional to the measures of two corresponding sides of another triangle, and the included angle is congruent, then the triangles are similar. So down at the picture at the bottom, we have angle A is congruent to angle D, and AB over DE equals AC over DF. Now notice that angle A and angle D are the angles in between the two sides. So angle A is between AB and AC, and angle D is between DE and DF. This is what an included angle is. Example 1. In the figure, AB is parallel to DE. Which theorem or postulate can be used to prove that triangle ACB is similar to triangle ECD? Now right off the bat, we should know that A is the wrong answer, because there is no ASA postulate or theorem with similar triangles. So what do we know? If AB is parallel to DE, then angle BAE equals angle AED by alternate interior angles. Also, angle ACB equals angle DCE by vertical angles. And finally, angle ABD equals EDB by alternate interior angles. Which does this go along with? This goes along with angle-angle because at least two corresponding angles are congruent. Example 2. We need to find AE and DE. Note that AB is parallel to CD. Since AB is parallel to CD, angle A equals angle D by alternate interior angles, and angle E equals angle E by vertical angles. So by angle, angle, we have triangle ABE is similar to triangle DCE. So step 1, we need to set up a proportion. So we have AB over its corresponding side DC equals AE over its corresponding side DE. And then we plug in what we know. So 2 over 5 equals x minus 1 over x plus 5. Step 2, we have to cross multiply and solve. So when we cross multiply, we get 2 times x plus 5 equals 5 times x minus 1. And now we distribute the 2, so we get 2x plus 10, and we distribute the 5, so we get 5x minus 5. So we get 15 equals 3x, and x equals 5. Now finally, step 3, we plug back in. So we have AE equals 5 minus 1, which is 4, and DE equals 5 plus 5 equals 10. Our last example. A pole is standing 2 meters tall. The shadow it casts is 3 meters long, and the distance from the shadow to the tree is 30 meters long. What is the height of the tree? Now, if you look, we have 2 triangles in the bottom picture. We have the triangle created by the 2-meter pole, and we have the big triangle created by the tree. So we're going to set up a proportion. Step 1, set up a proportion. So we have the length from the tree to the end of the shadow over the length from the pole to the end of the shadow. Now if you look at our 2 triangles, those are our corresponding sides. And now we have the height of the tree over the height of the pole. Those are our other corresponding sides. So now we plug in what we know. We have 30, which is the length from the tree to the end of the shadow, over 3, which is the length from the pole to the end of the shadow, equals x over 2. So x is the height of the tree, which is what we're trying to find in the problem, and 2 is the height of the pole. Step 2, cross multiply and solve. So we have 2 times 30 equals 3x. So x would equal 20. And that's the end of our slideshow. If you have any problems, come to my office hours, or you can contact me through the contact page of the website.